we introduce present quantum gravity, a novel non-perturbative discrete description of gravity and matter. At the core of our proposal, there is the assumption that only the present instant exists. The present is interpreted through the lens of time-symmetric quantum mechanics and holography. It is described as an ontological memory which evolves in atomic instants. This memory encodes the information potential existing in a fuzzy Euclidean space. This interpretation of time is compatible with relativity. The present instant is not intended as a common now, but the maximum rate of change and the sampling frequency of evolution. In this description, events are ordered in a causal set along an emerging classical causal time. They belong to an irreversible past, as we cannot change something that does not exist anymore. The fuzzy space represents the space of possible events. It is described through a Wick rotation, and it is therefore called the imaginary space. The information potential encoded in the present is defined in terms of possible events location and possible events order, respectively intended as non-locality in the imaginary space and undefined causality across the instants. Given the relation between causal non-separability and cyclicity of the causal structure, we describe non-locality and undefined causality in terms of time-symmetric possible paths which superpose in loops. Loops in time, which develop in the thickness of the present, encode the undefined locality of possible events. This non-locality in the fuzzy space is intended as an entanglement in space, and it is described through a tunneling potential. Loops in space, which develop as imaginary closed paths in the fuzzy space, encode the undefined order of possible events. This undefined causality across the instants is intended as an entanglement in time. The opening of such loops is a disentanglement, and a post-selection of a path that has causally occurred. It is a new event in the causal structure behind the past boundary of the present, and an extension of the particle actual path, which emerges along the causal time. The elementary observer of our framework is a massive particle. It is described in terms of loops in time and in space, respectively connected to its non-locality and spin. We describe its non-locality through loops in the thickness of the present. These loops in time, which are mapped to a perspective from the boundary of the imaginary space at null and infinity, encode an entanglement in space. The particle's half-spin, on the other hand, is encoded through loops in the fuzzy imaginary space. These loops in space, which extend in an undefined causality across the boundary of successive instants, encode an entanglement in time. The relation between massive particles and entanglement in time is at the core of our proposal. In this framework, spacetime does not ontologically exist. A massive particle experiences an emerging spacetime as it entangles between collapses along an elementary differential evolution. Its proper time is related to a subsampling of the universe ticks. It is derived from a limit on the information in the causal cone, and it is equivalent to the number of instants between collapse events experienced by the particle in an undefined causality. In the context of entropic theories, we relate the information hidden by a mass with an entanglement in time. We describe curvature as a symmetry breaking of entanglement in the fuzzy Euclidean space. This asymmetry in space is a back-reaction to the information hidden by the mass through entanglement in time. From this symmetry breaking, we explicitly derive the Newtonian potential and the Schwarzschild metric. In short, according to our proposal, matter hides information through entanglement in time, while the fuzzy space seeks this missing information, breaking the local spherical symmetry of entanglement in space. Concluding, the assumption that only an atom of time is real represents a compelling perspective in the context of a universe described through information. Moreover, the suggested relations between entanglement in time and matter, and between a symmetry breaking of entanglement in space and curvature, seem to hint at something deeper. You will find more in the paper, including a model of black holes, and the draft for a tabletop experiment that could provide evidence for our proposal. Present quantum gravity is still in its infancy, and some aspects need a more rigorous derivation. Join our quest. And remember, there is no time like the present.